This lesson is titled Factoring Trinomials, but this one's actually a little more specific. We're going to be factoring trinomials in which the number in front of the variable squared is not 1. So how do we do that? Well, there's a couple ways you can do this. The first way is the guess and check. So if we factor into two parentheses, you go with that front term. Now what you're going to do is those are going to be in the front positions of your parentheses. And now, so you have to think about what are your factors of 3, which in this case is only 3 and 1. So we could place a 3p here and a 1p there. Now, what I like to do also is establish what your symbols are. What are the symbols that are inside your parentheses? Well, if this last symbol is ever a plus, that means the symbols inside the parentheses are going to be the same exact symbol. Either two negatives or two positives. And so that's when we look to this symbol up front, which means there's going to be two negatives inside the parentheses. Again, if this last one is ever a plus, that means same exact symbol, two negatives or two positives. So we look to the first term to determine that. Okay, now we have to worry about the last term in both parentheses. Well, these two will multiply to equal 4. So now we have options here. You have 1 and 4, you have 2 and 2. So this is kind of like a guess and check method. So if I were to put a 1 and a 4, the way I figure out if I did that correctly is I would have to do the outer, so the FOIL method, do the outer and the inner and see if they combined to make a negative 8p. In this case, that gives me a negative 12p. The inner one gives me a negative 1p, which is not negative 8p. So I have to try a different combination. I can switch the 4 and 1, or I can try the 2 and 2. So let's do that. If I put a 2 and a 2 here, when I do the outer, that gives me negative 6p. The inner, negative 2p, which makes negative 8p. So I know that this is the correct parentheses when I factor. Now the other option, besides the guess and check. Now see, the guess and check, especially if you have bigger factors here, could take a while. And you have to try a bunch of different combinations. But there is another method. It's going to be factor by grouping. And that method, if the trinomial can factor into two parentheses, guarantees that it's going to work. Or the method, you stick to the same method and it should work. So here's the method with factoring by grouping. You take your front term. Now in standard form you have ax squared plus bx plus c. What you're going to do is you're going to take the a and the c and you're going to multiply them together. So in this case you take your 3 and your 4, you multiply them together, and you get 12. Now what you're going to do is you're going to find factors of 12. You have 1 and 12, 2 and 6, 3 and 4. Now the question is which pair of these will add up, since again we already established that when you do the two parentheses it's going to be same symbol, which ones will add up to 8? In this case the 2 and the 6. So what you're going to do is you're going to rewrite your trinomial, but what you're going to do is you're going to take that negative 8p and you're going to split it up to be negative 2p and negative 6p. So you're rewriting the negative 8p. I'm going to bring that 4 down. Now it doesn't matter which one you want to put first, negative 2p, negative 6p. Again, we established that they're both going to be negative. So what you're going to do now is you're going to take these front two terms and you're going to factor out what they have in common. In this case, they both share a p. If you factor out a p, you're left with 3p minus 2. You factored out a p. And again, factoring is another form of a type of dividing out. So you're dividing out a 2. Now here, you're going to factor out what those two have in common. But I will say if this first term on the second set is ever negative, you're going to factor out a negative with it. So 6 and 4, 2 goes into both of those. So negative 6 divided by negative 2p gives us a positive 3p. A positive 4 divided by negative 2 is a negative 2. And notice here, when you do that, your parentheses are the same. So what we can do now is treat these as two terms sharing a common factor, and that common factor is the parentheses right there, 3p minus 2. And when you factor that out, you're left with p minus 2. Notice that's the same answer we got when we did the guess and check. Again, if you like guess and check, that's fine. But this method, factor by grouping, it is one or two more steps, but it's guaranteed to work if the trinomial can factor into two parentheses. So I'm going to stick with this method for the sake of this video for the rest of the time, just to show the consistency with this method. So here we have 2v squared plus 11v plus 5. Excuse me. So again, you take the 2, you take the 5, you multiply them together, you get 10. That doesn't look like a 10. You get 10. Now our factors of 10 are 1 and 10, 2 and 5. So now we need to establish, are these going to be the same symbol or the opposite? So here we have the same symbol. So that means they're going to add up to negative 11. So in this case, or sorry, why did I say negative 11? They're going to add up to 11. So in this case, the 1 and 10 are the factors you want to use. So, you can rewrite as 2v squared, but instead of saying 11v, we could say 1v plus 10v plus 5. And now, again, we factor by grouping. What do those have in common? V. Leaving you with 2v plus, and don't forget, if you factor out from two terms, there's going to be two terms left in the parentheses. So v divided by v. Anything divided by itself is a 1. And here, they both share a 5. So a positive 5. So you factor out a 5, you're left with 2v plus 1. So here, again, we have the same exact parentheses. So we could factor that parentheses out, leaving us with 2v plus 1 and 1v plus 5. Now I will say this is a problem that if I were doing this one, I would have done the guess and check solely because you have prime numbers on the front and back, which makes the guess and check a little bit easier. But I still want to show you again this method, the factor by grouping method. Let's do another one. So you have 4 and negative 25, which gives you a negative 100. So you need to find factors of 100. And for the sake of this, this next couple steps, I'm actually going to leave off the negative. So I'm going to come up with my factors. 1 and 100, you have 2 and 50, you have 5 and 20, oops, I forgot 4 and 25, and you have 10 and 10. Now, here's the deal with this minus right here. If that's ever a minus, that means when you factor this into two parentheses, they're going to be opposite symbols, which means they're going to have a difference of 15. They're going to have a difference of 15. So which factors have a difference of 15? In this case, it's going to be the 20 and the 5. But one of them, since they're opposite symbols, one of them needs to be negative. Well, in order to get a negative 15, the 20 is going to need to be negative, and the 5 is going to be positive. Again, we need a negative 15 in the middle. So now we're going to rewrite our trinomial. It's going to be 4n squared, and again, it doesn't matter if you want to start with the positive 5 or the negative 20. You choose. So in this case, I'll just do the positive 5n minus 20n minus 25. So now, factor the first two. Those only share n, leaving you with 4n plus 5. And then here, remember if I said if that's ever a negative, that the first term of the second set, you want to factor the negative with it. And they both share a 5. So negative 5 I'm going to factor out. So negative 20 divided by negative 5 is a positive 4. We have the n there still. Negative 25 divided by negative 5 is a positive 5. And again, same exact symbol. So we could rewrite it as 4n plus 5, n minus 5. And there we go. It's factored out. All right, let's take a look at a few more examples here. Now, when it comes to factoring, and I probably should address this at the beginning, you should always ask yourself these two questions in this specific order. The first question is, can I factor anything out from all of the terms? The second question is, can I factor into two parentheses? Because there are going to be some trinomials that you can factor a common factor out from all three terms before you even go to two parentheses. And here's a few examples like that. Here you have 9k squared plus 66k plus 21. So the first thing you can do is they all share a factor of 3. So I can factor out a 3. Now that 3 doesn't go away, it just comes out front, leaving you with 3k squared plus 22k plus 7. And now what I can do is I could focus on the inside here and see if I could break that down into two parentheses. Now I'm going to show you one example here of the guess and check. And so I'm going to veer away from the factor by grouping for the rest of this problem. So we still have the 3 out front. That doesn't change. It doesn't go away. What I'm going to try to do is break this into two parentheses. And the reason why I'm doing guess and check on this one, again, is because I see a prime number up front and a prime number in the back, which makes factoring the guess and check method go a little easier. So that first term, 3k squared, well, your only options are 3 and 1. So 3k and 1k. And now we think about our symbols. That's a plus, which means same. The two symbols are going to be the same. I look here and go, oh, they're going to be two pluses. Now on the back side, my only combinations I have to make 7 are 1 and 7, or 7 and 1. So because I'm limited to so many options, that's why the guess and check method can go pretty quick on a problem like this. So if I were to put a 7 here and a 1 here, I just do the outer and inner to make sure that the combination is a 22 on the inside. So that's 3k and 7k. But that adds up to 10, so that's not going to work. So all I have to do is switch these up, put a 1 here and a 7 here. And that gives me 21k and 1k, which is 22k. So there goes our answer. 3 times 3k plus 1 times k plus 7. And again, you could have used the factor by grouping method, but when you have primes in the front and primes in the back, the guess and check is going to go a lot quicker. Okay, another problem here. So 15n squared minus 27n minus 6. Again, what do they have in common? In this case, they all share a factor of 3 again. I'll go blue. Which leaves you with 5n squared minus 9n minus 2. So factor what they have in common first. So I see here I have a prime and a prime, so I'm going to do the guess and check. So I bring the 3 down, and I make my parentheses. Well, the front, this 5n squared, my only options are 5n and 1n. Now I see here that there's a minus. I don't know what that is, supposed to be an arrow. I see that that's a minus. That means I have opposite symbols. Now before I just go ahead and throw in a negative and a positive, I need to realize that because there's a 5 up front, it does matter where the plus and minus goes. Now let's think about these numbers. So I'm going to throw in the symbols at the end. So that gives me a 2. Factors of 2. My only options are 1 and 2 and 2 and 1. So I'm going to do a little guess and check. I'm going to put a 1 here and a 2 here. Now because it's opposite symbols, those the outer and inner by themselves, disregarding symbols, needs to have a difference of 9. So when I do the outer, that gives me 10n. The inner gives me 1n, which does have a difference of 9. But I need to take in consideration that I need a combination of negative 9. So if that's the case, the 10 needs to be the negative one. and the one n needs to be the positive one. That would give me a negative n, 9n on the inside. So again, that needs to be the plus, the 1n needs to be the minus. And there you go. So there goes my factor trinomial. 3 times 5n minus 1 times n plus 1. Let's do one more of those. Now, on this one, you have negative 16b squared minus 6db plus 100. Notice there's a negative out in front. If there's a negative out in front, we should factor that as well. So in this case, they all share negative, and they all share a factor of 4. So I'm going to factor that out first from all three terms. And when I do that, I'm left with a positive 4b squared. Negative 60 divided by negative 4 is a positive 15b. And 100 divided by negative 4 is negative 25. Now I'm going to switch it back. I'm going to go back to the factor by grouping for this problem, just to get one more example of that. So here, I'm going to take those two numbers, 4 and 25, which gives me 100. And I'm looking for factors of 100 that are 15 away from each other. Now I know I'm not going to use 1 and 100. That's just too big. So I can start with 4 and 25. There's 5 and 20. 10 and 10. Those are supposed to be zeros. They look like sixes. Sorry about that. Okay, again, that's a minus, which means they're going to be opposite symbols in the parentheses. So they have to, my factors need to have a difference of 15. So in this case, that's going to give me the 5 and the 20. So I'm going to rewrite my trinomial. Now I'm going to bring down that negative 4. But on the inside, I have 4b squared. I get to choose. Sorry, I don't get to choose. Hold on. Opposite symbols. So we need a positive 15 on the inside. So one of these needs to be negative, the 5 and the 20. Well, to get a positive 15, the 5 would need to be negative, and the 20 would be positive. So I'm going to put a negative 5b plus 20b minus 25. And again, I'm going to factor what they have in common. In this case, they have the b, leaving you with 4b minus 5. Jeez, I really apologize about the handwriting. 4b minus 5. Factor out what those have in common, which is a 5, leaving you with 4b minus 5. And again, if you do this correctly, those should be the same exact parentheses. So our final answer now is I bring down that negative 4. I'm going to factor out that 4b minus 5 from those two terms, and leaving you with the b plus 5 for my second parentheses. So this would be my final answer. Again, that negative 4 doesn't go away. It just gets factored out front, and it stays out front. Now, how else could understanding the factor by grouping make things go faster? Well, what if you had a random trinomial in which was created, and you were asked to factor this? Well, understanding that method of the factor by grouping could speed up the process of understanding if that trinomial could be factored. Because if it could not be factored, then it's considered a prime polynomial. So we do the same first steps. We have 4 and n, which gives us 4 times n, which is 36. Now right away I see that's a plus, which means in the parentheses they're going to be the same exact symbol, which means they're both negative. That means those factors are going to add up to 2. When you think about it, all the factors of 36 which one of these add up to 2? None of them add up to 2. Those don't add up to 2. No, 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 no. That means this trinomial cannot be factored into 2 parentheses. So it's definitely it's considered a prime trinomial or a prime polynomial. So again, doing this method of multiplying the first and the last, the a and the c, and finding those factors, that could speed up the process of figuring out if you even could factor this out into two parentheses. That could be faster. In my opinion, this way is faster than doing the guess and check, because then you're going to have to guess and check every combination to make sure that that outer and inner doesn't make 2, as opposed to this where you just list your factors of 36 and you'll know right away that this will not work out. So hopefully this video helps, and good luck with factoring trinomials.